Okay, well, welcome everyone to the February webinar of Aerobridge. If you are new here, Aerobridge is a open source project and a community, and we mainly work via Slack. So if you go to aerobridge.io, there will be a sort of a link where you can join the Slack community. So all you're going to see here today, you can participate by joining that Slack channel. This is a series of webinars that we organize every so often. Basically, the last one was in August. We shared an update in October, and basically this is something that we've been planning to do in December. So even if you miss this one, there will be additional ones down the line. We normally plan 3 to 4 webinars as the project progresses. And essentially what we're going to do is just share with the community all the things that we've been up to in this space. As you know, things move very fast. But what we're going to talk today about is about some important updates that we have been working on as a community. Again, everything that you see is open source. It's on GitHub, and the best way to engage is to join the community. Every Thursday at 7 o'clock, we have our weekly developer call, so you can if you're free on 7 o'clock on a Thursday, Indian time, you can join there, or as I said, join the Slack. My name is Rishi. I am the lead developer of Aerobridge, and what you're going to see is a set of work that me and my colleagues have been doing over the past 3 or 4 months. Just a little bit of a background. I run a company called Open Skies, and Open Skies, Aerobridge is a project under that. And in fact, there are many other projects within Open Skies. Aerobridge just one of them. The most notable ones are what is known as Flight Spotlight and Flight Blender, which is if you're familiar with ASTM network remote ID or those kind of part of things, this is what is called as a display application and data processing engine for compliance with remote ID. So if you're interested in that aspect of things, I would encourage you to take a look at the GitHub page. Then the other project that is interesting is what is known as Flight Passport, which is basically a identity and authentication server based on OAuth, which powers some of these things that you're going to see. And of course, Aerobridge, the management server, and some of the GCSs and so on. So there is a link to the GitHub page at the bottom. You can take a look. There is a lot of projects that we are sort of leading and implementing, and you can take a look at that. What I want to do today is to talk to you about trusted flights and sort of lay down the scene for all the work that we're doing at Aerobridge to give it some context. Trusted flight borrows concepts from trusted computing. Basically, what it says is that it gives hardware manufacturers control over what software it can and cannot run. And the next step to that being, it can actually deny unsigned or untrusted software from running on these computing platforms. Now, trusted computing has been around for a number of years, and we are using those same concepts of trusted computing into what is known as trusted flights. And so what does that mean? That means that you have control over who is flying the drone, where the drone is made, and what technology has been used. Of course, Aerobridge is a project that is deployed in private companies and small manufacturers and small operators. So if you deploy this Aerobridge stack that we are going to share with you, you get to sort of dip your toe or put your feet into what is known as trusted flights, where you have operational control over who is flying, where the drone is made. We will talk about some manufacturing improvements and also what technology is being used. So you can start to say, well, if the token that we produce is not made by my company, the flight will not fly. So all of this infrastructure normally is deployed in private companies, and in the same way, this trusted flight infrastructure will be deployed in your own private company. So essentially, if you have a company and you run Google Cloud or Amazon AWS or any cloud computing system, you can take this and deploy it within your infrastructure. The other thing about this is because this is open, you can integrate it with your existing stack. So if you have a certain piece of software already running, you can be able to integrate this. So trusted flight looks like this, as you can see in my screen. Basically, you go from the very bottom of the stack all the way up to the top to the UTM. Now, of course, we are going to talk about integrations with ArduPilot and PX4. And in fact, we're going to talk about hardware as well. Then we have a sort of these security layer added to QGCS. And of course, everything is controlled via the management server. So you can see here, we are going up and down the stack, right from the firmware level all the way to the management server. And eventually, when you have a policy for UTM, you can integrate it. If you have a UTM product that you're selling in the market, Aerobridge can be integrated into it. At the moment, we have integrated it into the DSS and the inter-USS and so on. I'm one of the sort of the contributors to that. But the point that I'm trying to make to you is that as the UTM framework develops, particularly in India, you can integrate Aerobridge into it. But if you have a UTM product or UTM APIs, you can integrate that into Aerobridge as well. We are indeed talking to a few UTM companies to integrate Aerobridge into it. Again, all of this is open, and this security layer, this trusted layer, we call it Aerobridge Guardian. So the Guardian system is essentially three things at the moment: the management server at the top, a specific fork of QGCS called Aerobridge Guardian, which we will show you, and then a sort of a specific implementations in ArduPilot. The good thing about this is that once we do it in ArduPilot, then we'll take PX4 and then any other proprietary flight controller that you may have. So the idea here is that we build these security systems first in the open and then as necessary to other flight controllers as well. So here's basically the broad concept of trusted flights as is implemented in this open stack that you see. The heart of this is a what you would call as an OTP or a specific form of OTP called JWT. Now, OTP, if you don't know, is called a one-time password. Basically, this is the thing that you get on an SMS or something like that, where you say, if you want to log in, enter this password. The same concepts have been applied to flights, where we say, if you want to fly, you need a token or a ticket. And that ticket is issued by a OAuth server. Now, OAuth is a sort of a standard technology. It is an internet and a well-known standard. So there are many products available for this. You can use Amazon Cognito, Azure Identity. There is a Google Cloud Identity, or any of these other many companies that you have, and issue these tickets, right? So the fundamental thing to know here is that the heart of the Guardian system is this notion of an OTP or a ticket that is issued by open and freely available technologies. We happen to use a OAuth server called Flight Passport, which I have written and essentially is specifically tailored for UTM and USpace and so on. But you can use any one of them as necessary. What happens is, once you make a flight plan in the QGCS system, so you open up your GCS, you log in, you will see all of this shortly. You make a plan, then the plan is sent to the management server, who then checks various things, including things like the UTM side and others, and then issues a basically what is known as the JSON web token. So it's basically a ticket, but instead of just having yes or no, it has many other data that you can embed in a JWT, which makes it interesting. The JWT is then downloaded back into the QGCS. So this ticket or this token is downloaded back into the QGCS system. You verify that on the GCS. So there are standard procedures to verify these tickets. As I said, these are all open standards. So there is a particular way to do it. And then once that JWT is verified, that token, that ticket is verified, then you send it to the RFM, and then you sort of verify it on the RFM as well. So this is what I would call as a double verification, a two-step verification, where the ticket issued by your company's server is verified twice, once in the GCS and once in the RFM. And then essentially, if everything is okay, you can arm and fly the mission. And then we have plans to upload all of this data back into the management server. So what you're seeing here is a concept of a one-time token, a time-limited token that is generated by the OAuth server, managed by the Aerobridge, sent to QGCS. Then at the moment, we have an Ardupilot integration, but the thing is JWT and OTP is kind of standard across many sort of use cases. So eventually we'll tackle PX4 and any other proprietary autopilot that there may be. But the concept is this, where basically we are controlling how and when flights can be armed. We are controlling who can access it, and we are controlling which companies can issue some of these tokens. So you can have a great level of control over these OTPs. This is just the same thing in a different fashion. This is what you will see shortly in the demonstration. You submit a flight plan. So this is the GCS and this is the drone. You submit a flight plan. Then this is generated. A plan ID is generated. Then you can say, well, I want to fly. And then you can check the airspace example, DSS, Digital Sky, whatever UTM and permissioning system that you may have. And then you sort of send it back to the GCS and then to the drone. I will leave that here for 1 minute, and then I'll jump straight into how this looks like in Aerobridge. So let's just switch. There we go. So if you're new to Aerobridge, as I said to you, we have what is known as a test flight server, which is basically the latest build of the code as the code develops. Aerobridge, of course, is on GitHub, and essentially we will sort of share with you these updates as they go along. But what we're going to see now is really three things: the management server, which I will just show you, which forms the Guardian system; the Guardian GCS, which we will have a very short demo of this; and then, of course, the hardware, which will verify these OTPs. Essentially, we call it F1, and this is a new reference, Open Small UAS hardware, that we will talk about a little bit more. But the idea here is that we are going to show you all three of how these works. Again, so this is the test flight server. So this can be deployed on your company if you have an interest. Of course, this is a sort of any cloud provider should be able to host it for you. Essentially, there is a backend API specification. So if you look at the backend, if you're technically oriented, Aerobridge comes with a very elaborate API for your GCS and other systems to talk and sort of interact with it. But what I want to show you is the front end. So essentially, if you look at the test flight here, this is the landing page for the Aerobridge Guardian system. And here, the first thing you have to do is, as you would expect, a very simple fleet and identity management sort of a solution. The interesting thing about this is that this is connected to OpenID. So if you have OpenID Connect or any of those, you can import some of these things directly. But the idea is here you have a list of pilots, here people, here you have a list of some operators. As I said to you, Aerobridge is flexibly used by operators and manufacturers. So I'm talking about operators, people who want to do some photography, some inspection, things like that. And then we'll talk to manufacturing as well. But all of this can be customized for your use case. Now, here I have basically one manufacturer called Aerobridge, and then I have a model called Aerobridge F1, which we will show you. This is the detail of my aircraft. And then I'm going to basically go into the trusted flight section. Here you have an aircraft, which is the number one F1. So basically you can say this is the first F1 in my fleet. Everything as you would expect. There is photography, there is flight controller number, the manufacturer, who's made it. So the idea that you can have a fleet of drones from many manufacturers, including yourself, Aerobridge can tackle very nicely. And then you can have, which we'll get to, is basically an assembly sort of an aspect as well, where you can build out the whole assembly for an aircraft. Now, there are three sections here, which is what we would call as a pre-flight section. As expected, you could file a plan from your GCS, or you could sort of upload a plan. So you sort of file these plans. Plans then become operations. Basically, you say, this is my path, and you can store it. These are, of course, all standard trajectories and so on. So if you're using ASTM type terminology, you can use that. If you're using GeoJSON, you can use that. If you're using KML, you can use that. In this case, in the Guardian system, we are using QGCS, so we use the QGCS format. So the format doesn't matter. Think about what's going on. You have plans. Plans become operations. Operations have things like start time and end time, kind of operation it is, who's making it, and so on associated with it. So you have all of a sudden a very standardized way to interact with all of your company's operations. And then, of course, operations have these OTPs associated with it. This is what the JWT looks like. So if I just copy it and just go to jwt.io, or as I said to you, these OTPs are based on, let's say, standards. So you can just paste it here. Here you can see who's issued it. So id.openskies.sh, this could be your server. What's the subject? What's the flight plan ID? And so on. So all of the things that you would expect in an OTP are embedded in it, except instead of being it a single numeric digit, you can actually have a bunch of data inside the token itself. Now, all of this, you don't have to see. You can see it in the GCS itself, as we will see shortly. But the idea is that you have a sort of a standardized way to manage and store your operations. As I said to you, some of this can be sort of integrated with your existing thing. So no matter what you have already existing, you should be able to integrate all of this into it. The most interesting thing about it is that because you're using these JWT type tokens, it is all standardized, and you can sort of, how do you say, standards compliant. Now, that is the management server. There are some other things. You can have credentials and files and so on. But conceptually, what you are doing here is using this server to manage all your operations. Now, coming back to our sort of the GCS side, I want to show you how this can look like on the GCS. Basically, the server is there, and you set up the people and the aircraft and so on. And then now we take a look at how this server interacts with the GCS. And as you would expect, it does all these checks and sort of communication with the GCS. It doesn't use the front end. There is, as I said to you, a very elaborate API associated with Aerobridge, and you will see basically that API working shortly. So with that, I'm going to stop, and I'm going to let Vibhu take over, who is our community lead and sort of really a great engineer on showing how the GCS would work.
Yep, thank you so much, Rishi, for the introduction. Hi everyone, I am Vibhu, and I will be covering the QGC side of the things. I'll be demonstrating these 9 different operations that the QGC in this whole Guardian stack would work. So the first step would be for anyone would be to clone the QGC fork of the master branch from the Open Skies repository. And after cloning, what you can do is you'll have to set up the configuration file. So a configuration file looks like this, where you have client ID, client secret, and a bunch of other parameters. Once you set up these client ID and client secret in the root directory of the QGC fork, you can just execute and launch the QGC. You can also follow the same steps as in the normal documentation of the QGC, the official documentation of QGC. So once you execute, this will launch the Aerobridge Guardian QGC, which is a slightly modified version of QGuard control. Here you can see first what it does. It tries to connect to the server. Once it connects to the server and the client secret and everything is verified, You can connect your drone or your flight controller to it. You can see there are these three different checks that this carries out. So first is it connects to the flight controller. Second, it checks the drone registration status. So as Rishi showed in the management server how you can add a drone. And the third is the key rotation. So key rotation, what happens is it just uploads the public key from the drone to the management server. So all these three steps once done, you'll get this default view of your ground control station. Now the next step would be to create a plan and create an operation and then get the permission. So these three steps I'll quickly try to demonstrate. So what you can do is, so I already have this plan. Let's say, so I create a new plan from here after, yeah. And let's create a survey mission. I create a basic survey mission in this area, and yeah. And once this is done, once you have created the survey, you can upload this plan file to the management server, and you can also like track what every time you create a plan you upload, you can also see the same in the plans directory. So once I upload the plans in the management server, like let's say I create a plan named mapping operation A, and I'll once the plan has been uploaded, I can also check the same. I'll get this message, flight plan uploaded successfully. Yeah, and once I get the message, you can also track the same here. You can see that there's a new plan added in the management server as well. And once you have created the plan, you can create the plan into an operation. And how you can do that is you can go to Guardian. You can there's an option called pick a plan, and you can see all the different plans that are in the management server for that particular drone. And you can select the plan. I select the mapping operation 1, and you can see the plan automatically loads from the management server in the QGCS. And I can again modify it, or make some changes and again create a new plan, or maybe I can create this plan into an operation and get the permission. So using this button, let's say operation A, it's a visual line of sight flight. Yep, so it says flight operation created, and it's waiting for clearance from the management server. So management server does a lot of backend operations, like communicating with inter-USS, checking any deconfliction, checking the airspace and everything. And yeah, and within a few seconds you get the option called you get a response called permission granted. And as long as you don't get this permission granted message, this upload button won't be activated, so you won't be able to upload this mission to the drone. So this is how we secure trusted flights as well. And it's a kind of uh, a way to uh, way for operators and manufacturers to make sure that the drone operations are very safe and secure as well. So that's it. I think if you have any questions, you can reach us out on Slack. So this thing that you have seen, this demonstration was developed by Kapil. He is very dedicated worker, dedicated developer of our community. And yeah, that's it. Any other things? Rishi, have I covered everything?
Thank you. No, you have covered most of it. If you just open back the 9 steps that yeah.
Yes.
So basically what happened here is, with the creation of the plan to getting the OTP, is what Vibhu demonstrated. Of course, because it is done digitally, it is done immediately. But at the back end, all of this is happening. Essentially, what we are saying is that you can have a system to say, I will not give you an OTP because maybe you don't work with the company or because you're using a drone that has been deactivated. If you noticed in the GCS side as well, there was this firmware update as well. So I will not give you an OTP because your firmware is out of date and so on. So you can create these sort of rules, let's say, to grant an OTP. And this is what happened. What is more interesting about what's going on with Vibhu's demonstration is that these are independent things. We have done it for QGCS. If you have your own ground controller, you can use that. If you use Mission Planner, you can use that. We picked QGCS because we have people and skills who know how to operate and develop on QGCS. That's the first thing to do. Then, the next step would be to do it in the other ground controllers. Maybe if you let me share my screen, please.
Yep.
Okay, so let's continue. We have a lot more to share here. Just like there is a just for the sake of people who are interested in this, this is the Open Skies GitHub. Here you will see QGCS, Q Ground Control. And then here in that, there is the PR of Guardian, as you can see. And here you can see all the changes. This is quite a significant work. As you can see, eventually this will be integrated into QGCS. But essentially what you're seeing over here is the Guardian fork of Q Ground Control. In the same way, if you remember, I had said to you that OTP is verified twice. Once on the GCS and once on the RFM, right? And so if you look at the ArduPilot fork in Open Skies, if you look at the pull requests, here you have Rhythm, who's also with us, basically working on some of these ground control sort of aspect of it, where we are saying, here is how you verify that OTP in an ArduPilot setting. Once we figure this out, then we'll move on to PX4 and any other proprietary flight controllers as well. But the idea here is to provide these sort of methods for verification and integration with this OAuth stack for any other ground controller. Now, that is basically the hardware sort of side of things. But in addition to the hardware and the flight controller, we are working on a open flight stack through and through, right from the management server down to the hardware. And this is something that I would like to share with the community. Basically, in addition to developing open software, we are looking to develop a open hardware with open components and supply chain. And so that we call it our F1 small UAS. And what this is a reference design for hardware, utilizing best-in-class open source systems and software to do basic mapping operations in India. And what is interesting about it is that you can build F1 yourself, and or we can build it for you. And F1 is basically what you would call as a hobby drone. It is mainly for R&D purposes. It is mainly for sort of students and young people who want to get into the drone ecosystem and start these flights. So if you go to f1.aerobridge.io, this is f1.aerobridge. Here is the drone for that you can build. Basically, you know, this is very, very competitive and cost effective. If you know how to build it, we have people in the community who will show you how to build the drones. Just to sort of give you some parameters, flight time of 15 minutes, thrust to weight ratio of 1.8, an expected weight of 1.5 kilos, and a mapping area of 7 hectares. Vibhu is going to show you some of the computation on how these performance parameters were arrived so that you have an idea of how some of these sort of calculations can be done. Of course, that is also run in the open. We have a bill of materials for 13 components. So this drone has 13 components. We have a sort of a price per unit for it and an approximate cost if you decide to buy it yourself. The idea here is that you start with these 13, build a very simple mapping drone, and then try to do some mapping operations in the green zones. There are disclaimers and so on. But the idea, what you're going to see now, is how some of these fit in to the management server. So what you have seen till now is Aerobridge for operations and operators, but now we are going to show you how this will work for manufacturers and sort of integrating this hardware and software to build a sort of a manufacturing supply chain as well. So this is F1. It's a basic mapping drone. What I'm going to show you now, just because our community and the people who listen are technically oriented, is how do you calculate the flight performance parameters? There is a spreadsheet for it, which we will introduce it to you right now. And then we will start to talk about what this is and the 13 sort of components. Vibhu.
Thank you once again, Rishi. So as Rishi talked about the F1 drone, so you can also find a list of components in the website as well, and we also have this spreadsheet where you can find all the different components and their specification, and also one of the preferred link to buy that component as well. What we did was we referred to this research paper by David and Leonard from ETH Zurich. They did a wonderful job. I think this is one of the most I think greatest work for optimization of the range and endurance of a drone. And what we did was we did the same calculations for our F1 drone as well, using the same equations and the theories, the beta element momentum theory, and we have also included the battery model and the motor model as well. So the link, I think we can also share with in the community. You can join our Slack to access this spreadsheet. And the good thing about the spreadsheet is you can change any of these parameters. You can modify the weight or the propeller radius or any of these parameters, and what you'll be able to get is automatically it will tell you what will be the maximum endurance and what is the maximum range that particular drone model can cover. So there are a bunch of other constants and coefficients. So these are directly taken from the research paper only. So there are these two motor coefficients and battery coefficient. We'll be also adding the wind coefficient in a week or two, where we can also consider some of the effects of wind on these parameters. Specifically on the endurance and the range part. So yeah, so I can also demonstrate if I try to change the parameters, if I reduce the weight of the drone and maybe increase the battery capacity, or maybe just increase the number of cells from 3s to if I make it 4s, you'll see a drastic change in the endurance. The endurance has gone up to 40 minutes, and the range it can cover is somewhere around 27 kilometers in a straight line. And this has been optimized using a bunch of different parameters. And yeah, if you have any questions, if you want to know more, or if you want to interact with this spreadsheet, you can join our Slack channel, and yeah, we'll be happy to help you out and maybe integrate a few more other features as well.
Right. Thank you, Vibhu. What we are doing is giving the community hardware. We are giving them the method to make a mapping drone, and also tools to understand and figure out how these computations are made. So think of it as foundational building blocks. If you are listening to this and you are in a university, if you are thinking about getting into the drone space, you need to understand these basic things. And what I'm saying to say to you is that now there is a community to do this. It is not magic. It is not some sort of a thing that only a few people know. You need to jump in and start playing with those simple spreadsheets to understand how these components work together. I have a few other things talking about components. As you know, basically this has 13 components in it. And so this again has been developed by let's say a peer review within the community. We are going to build out these test kits and sort of a hardware reference and so on. What's interesting about them is that basically we have optimized it for this sort of a price sort of aspect, and then some basic sort of endurance. So this is not obviously anything interesting. You would call it as a next one step up from a toy. But as you can imagine with these things, things will get better and better and better over time. Now, what's happened recently is essentially this notion that you would want to build these components within India and have a supply chain for these components. So as you would expect, because this is a Aerobridge drone, this is well integrated into the management server. Again, if you have your own management supply chain and drone and so on, you can integrate it. But basically in Aerobridge now we have manufacturers, we have the models, that's the F1, and that's the master components. So essentially what you're seeing here is a way to sort of store and manage your supply chain for these parts as well. So what do you need? You need a model, you need a list of parts, and then you can integrate that into the Aerobridge side as well. There will be way more with this in the coming days. Essentially, we are building tools for supply chain transparency, eventually traceability, and also we're going to talk very briefly about the manufacturing side as well. But the point is, you can at the moment buy some of these from Indian-made manufacturers. We have a sort of a list of them in the community, and many of them are in the community. So for example, you will find a few of these components like the frame and so on, which is fully made in India. You can start to sort of build that network of manufacturers from the community as well. We, in addition to this, to sort of touch upon this, we have a sort of a special announcement with my friend and colleague Biswajit, who is going to talk to us a little bit about what we are doing specifically to address the manufacturing side of things. And I'm very excited that he's here. Biswajit, if you have a presentation, you can do that, or I can share my screen, however you want to do this.
Yeah, hi Rishi, hi. Thanks for giving an opportunity. Like you can share this screen. I've got no issue. Like I don't have any presentation as of now, but like yeah, a small brief introduction about like what we as a community are planning to do, especially for the college goers who want to you can say get into this drone space and start building stuffs. Like so, Aerobridge and Drone Helpline both have collaborated to come up with a design challenge, which we have named it as India Drone Design Challenge, and we are about to launch it in few weeks' time as we go, where we are coming up. Yeah, great. Yeah, thanks for sharing it. So we have planned, like the main motive of coming up with this drone design challenge is to make the young enthusiasts come into indigenization, the making the thing that the government is promoting. So yes, it's not possible for us to get everything ready from day one. So we have sort of divided the entire challenge in 5 to 6 different components. Like the first component will be designing the airframe, getting it validated in software, and of course it's not possible for everyone to 3D print it or get the live model ready. So we'll be helping them out, we'll be analyzing them, and we will be selecting the top 3 and we'll be making them live in their physical form. So we have the first part will be designing the airframe. The second part, yeah, Rishi, you can add like if I'm missing something out. The second part will be making them integrate electronics. Yes, we'll be giving them a set of problem statement, a set of criteria that they have to meet. We'll be keeping the entire thing transparent, as it will be an open source design challenge. And the third part will be integrating some payload and all. So like we have set a timeline. We have not yet decided and we have not yet released the timeline yet, but we'll be coming up with a timeline where the participants will get enough time to design their airframe, validate it, and once they're selected and they're shortlisted, we'll be printing them up, making them live. And then subsequently the second stages will open up. So very soon we'll be launching it out. I'm not yet disclosing the problem statement, resources that we'll be sharing and all, but like, yes, we have planned out that we'll be motivating the college goers, the enthusiasts to come up and design their own airframes, design their own drones, of course, integrating Aerobridge and other platforms to them in the later stage. Yeah, Rishi, like if you want to add something.
No,
that would be great.
you have covered it well. Basically, there are two things about it. This is the 22 version of it. And of the 13 things, we are targeting what you would call as the simplest one, which is the airframe and the landing gears. So this year's challenge will be focused on that. The outcome of this will be open. So we will publish the CAD drawings and whatever else for anybody to use. And then we hope to continue and build upon this momentum to have a 2023 version of the challenge and a 2024, or maybe a 2022 part 2 and so on. But the idea here is that you start to tackle some of these very difficult problems of manufacturing and lay down the groundwork for this. And as I said to you, these are not very, very complicated things in the grand scheme of things. So you should be able to have a frame, make it in India. We can have manufacturers in our community who can make it for you, and so on. And for the sake of our competition, we have two categories, CNC and 3D prints. And essentially, we are going to sort of try to get all the engineering colleges involved to form teams and then have this as a regular thing. We are focusing mainly on the airframes and the landing gear at this time. There is a rule book and so on. So as Biswajit said, this is a little bit under review. There will be judges and so on. But the idea here is that you form a team and then you enter this challenge if you are a student, if you have friends who are interested in this, and then we will have some sort of a judging criteria and so on. But the overarching goal, frankly, is eventually to make all 13 of these components in India. Some of them, of course, are going to take a long time. For example, semiconductors, that's obviously beyond our community's purview. But the idea here is that if you saw Vibhu's spreadsheet, some of them are mechanical components, some of them are electromechanical and semiconductors. So we're starting with the mechanical, then the electronic, and then the electromechanical, and then finally semiconductors. So you can start to think of it as a 2-year, 3-year roadmap where we can start to have competitions for each and every one of these 13 components. So this is the challenge. You will hear more from it from our side, certainly in the coming weeks. And essentially what we're going to do then is ask if you have colleagues or friends or students in your family or your network, then we would encourage them to sort of engage and start designing things and start building some of these drawings for this challenge. We have a lot to cover, and essentially, I want to take a small break here just for 30 seconds or so. And I know we have a few people from the iSpirit side of things. So I'll just take a 30 minutes and we're going to change gears a little bit. What we wanted to show you was basically the Guardian stack. Just to recap, we have a full top to bottom sort of an open ecosystem of trusted flight module, trusted GCS, and sort of security-oriented management server. When the UTM side is ready, or if you are a private UTM company, we can integrate that with your side. And essentially, from the hardware side with the drone design challenge, all the way up to UTM, we will have an open reference implementation. What I do want to sort of lay the groundwork for is what's happening in this sort of a side as you go higher and higher to do with the UTM side and the sort of the UAS ConOps and so on. And for that, we have a small group called Pushpak. If you're not familiar, Siddharth Shetty, who was with iSpirit, joined us in the last webinar. Essentially, there is a small group of people there who are working on these ConOps, and I would like, I think Sayan is here, to sort of just introduce that to us And we're going to use this opportunity to share with you a way to engage on that side. So if hardware and firmware and manufacturing is not your cup of tea, we're going to show you something that you can engage with on the higher side as well, and sort of contribute to the ecosystem.
Hi everyone. Thanks very much for the intro and fantastic stuff, by the way, Rishi. So far, I mean, a few things even I think we were also unaware of, right? But I'm Sandeep. Very nice to see all of you enthused guys in the Aerobridge community. Nihal also is with us. By the way, Rishi is also with us. We have a few more guys from regulation in the end of the spectrum, and a few more from and piloting as well, and then software development. So that's what we call Team Pushpak. We're sort of working with a few players, and hopefully with Aerobridge also we'll try a sort of test thing with UTM. So let me quickly share a few slides. Just give me 1 second. Okay, do let me know if you can see my screen.
Yes, we can.
All good. Okay, perfect. So what we're basically call ourselves Team Pushpak. So from the old flying unmanned mythological things, and we're part of the iSpirit. There's a lot of iSpirit discussions active. We call them rooms, and one of them, obviously, we've Siddharth Shetty set up this discussion a few years, maybe more back, with the initial NPNT push, and then with there was a little bit of a gap while the industry caught up with the regulations for NPNT. Aerobridge did a great job of open sourcing pretty much everything in the pipeline. Now, after that gap, we're sort of returning to what Digital Sky might look like in the very near future. So that's Digital Sky version 2.0. And now we plan to sort of inform the policymaking on more on the UTM side of things. So we have a couple of pilots. We have, so they're more from the regulatory end. We have a couple of software developers on the team. Sandeep, that's me. Siddharth is from Canada. Rishikesh, obviously there. And we have an a great all what do you call it, not potent, omnipotent, but he knows pretty much everything in policy making, Siddharth Shetty himself, right? So iSpirit, as you might or might not know, is a sort of a long-term think and do tank, not just think tank. They have a lot of other discussions in various other fields of policy making, so health being one of the most interesting ones. There's something in DEPA, which is digital empowerment. There's other open source initiatives as well. So maybe you can pay them a visit and see what they're up to. So Pushpak specifically focuses on empowering the drone ecosystem. So Digital Sky 1 came out of this room. At that time, it was a different group of people. Nihal was still there, if I'm not wrong. There were a few more software developers you might have met, Mr. Abhinav, Ashutosh Bhatnagar, right? I think. Abhirav Bhatnagar. So he was there. Nihal was there. iSpirit. There was Tanuj and Siddharth, and now it's sort of evolved into this next generation where we are focusing on more of building out a concept of operations, which will hopefully inform all the technical standards that come out in the near future for UTM, right? So that means traffic management. How do we enable India to catch up with what's been happening outside of India, particularly the inter-USS and all the other remote ID standards and so forth. So initially we started off with a ConOps for US. So it sort of builds out categorization of different types of operations, different weight categories, so as to enable policymaking in a much more streamlined fashion. And so we have the QR link up there. If you want to scan it quickly, in the meanwhile, just brief you on what it is. So it's sort of a user-oriented document that explains and sort of lays out a timeline for implementation of the development of the ecosystem will take time. We know that Aerobridge is very, oh, sorry. Are you still seeing my screen, hopefully? Okay. Yeah, I'm assuming yes. Okay, good. So so we've published this document, I think, pretty a while back, and then we did a couple of open houses and tried to explain this to a lot of people. I think I see some of them here as well. And now what we are currently working on is so we, alongside that, we obviously came out with a roadmap for US ConOps to be implemented. So some of that as actually with the new policy changes, actually they're sort of starting to line up, which is good. So we have this concept of category A operations, B and C. So increasing in terms of complexity and risk of the operations themselves, and also the weight categories of the drones involved. So while Aerobridge is doing a great job of starting us off on the right foot, we are trying to make sure that the goal, that the long-term goal, we don't miss out on it, right? So we enabling a slightly longer-term planning in terms of getting all the right building blocks for the UTM in place and making sure all of them are adopted by the Digital Sky platform. So short term, we have so immediate. I think we're on track with the new policy changes that's restricting imports. So that means better category A and B operations, which would be the bulk of operations that happen today. So typically survey and short range, long range, hobbyist, all these are in category A. Category B are slightly more complex operations where you need a bit more training for the pilot, bit more regulation, and those are enabled in our ConOps as well. So maybe we can get back in touch with us and we'll go through it in detail. And the long term is, okay, how do you integrate all this into a UTM? So that is what we're currently working on. So this is the active discussion right now. How do we enable the same concept of operations, what we have for the US, put it into a UTM context, make sure that we have the right building blocks for remote ID, monetization models. So a company who wants to start up a UTM sort of software, so to enable the ecosystem growth, can also do it in a way that he's not bound by too much of regulation. At the same time, he can raise money for it. So things like that. There's a lot of work that needs to be done on prioritization of the UTM of different kinds of operations and deconfliction, which we are just starting to get into. If you guys are interested, do get in touch, and we can definitely help bring in a sort of more wholesome perspective to the discussion. That's it from me. I think Nihal, do you have a few words, or maybe Rishi can sort of tie up the last bit into Aerobridge maybe. Unless there is any other questions. So we have our group email down there. Do make a note, shoot out an email if you have any other, if you need a follow-up and want to join in the discussions, even better.
Perfect. Thank you.
Okay, thanks very much.
Let me just conclude the webinar. Maybe if you can just stop sharing, Sven.
Sure.
So thank you. I want to sort of tie all of this together. The first thing I would say to you is that you now have many ways to contribute. If you want to talk about policy, Pushpak is there. If you want to talk about software, we have Aerobridge. If you want to talk about hardware and hardware design and manufacturing, we have F1 and the design challenge. You choose which part of this stack you want to engage in, and I hope that you have these sort of groups and people working on it and a way to do that, right? And these communities are open. There is no sort of requirement other than enthusiasm, interest, passion, and of course, dedication and hard work to the field. That is all that is required for you. Now, I want to conclude about why this is interesting in the long term. By adopting these open sort of systems like Guardian, like sort of the OpenUTM sort of type things that I've been discussing, you as an Indian company can be compliant to other external regulations like USpace in Europe and NDA and others in the US. So when we are building these technologies, certainly from an Aerobridge side, you will be compatible with other sort of countries, for example, in ASTM and so on. So by adopting standard technologies, you can be able to export and compete with these other markets as well, right? So the way to sort of do that is by sort of engaging. We have the drone, for example, try it out. Try the spreadsheet out. Try to see if it makes sense. If you have a question, ask the community. Ask, we have many people here who are sort of experts in that. And this is the only way you can start to compete at a sort of a global level. So I would really encourage you to sort of engage and contribute to some of these things, particularly if you're interested in now UTM and the ConOps side with Pushpak as well. With this, I want to conclude the webinar. We covered a lot. My name is Rishi. I'm just going to send my email for just a few minutes. But I also want to thank many partners and the community. Some of them are here, longtime collaborators, Rhythm, Mayank, Vibhu, Biswajit as well. And of course, the Pushpak team, Nihal is here and Sandeep as well. So I hope that this concludes the webinar and you get a good idea of where you would like to contribute. We would probably hold another webinar in the next 3 to 4 months, but that will be sort of announced when it's ready. As you can see, we have a lot to cover in the few months. With that, I'll just stop the recording and then we can have a Q&A if there is one. Otherwise, I'll let you go. We are sort of 2 minutes over time.